All right, chapter 13 worksheet YouTube video. The following data was obtained from a repeated measure study comparing 3 treatment conditions. Use a repeated measures ANOVA with an alpha level of 0.05 to determine whether there are significant mean differences among the 3 treatments. All right, so first you have to understand what you're looking at when you're looking at this ANOVA matrix. All right, you have A, B, C, D, E, F, right? So you have 6 participants that are in 3 treatment conditions. And it is a repeated measures ANOVA. So that means that these 6 participants participate in all 3 treatments. All right, you got G, which equals the grand total of all the scores in the treatments. You have the sum of x squared, which is the sum of x squared of all scores in the entire treatment. And you have big N, which is the total number of participants in each group, okay? Even though they are the same participants, they still are in each group. So big N is still going to be 18, even though these participants are all the same people. All right, so you got the means of each group, you got the T of each group, which is the total number of scores, the sum of the total of scores for each treatment. And you got the sum of squares of each treatment. All right, so then you follow these steps to solve the question whether there is a significant mean difference among the 3 groups. So degrees of freedom between treatments is k minus 1. There are 3 treatments, 3 groups, okay? Between treatments, between groups, right? You'll hear me say them both when I lecture because they mean the same thing, right? Between treatments, between groups, they're the same thing. So k minus 1 is number of groups minus 1, or number of treatments minus 1. 3 minus 1 is 2. df within is simply the degrees of freedom of each group. So we all know df equals n minus 1. So 6 participants per group. 6 minus 1 is 3 groups. 5 plus 5 plus 5 is 15. Find df between subjects. So df between subjects is number of subjects per group minus 1. Little n represents number of subjects per group. Big N represents number of subjects in all groups. Then find SS total. So all you do is you plug in the sum of x squared and you subtract G squared divided by big N and you get 56, right? It's very similar to the sum of squares formula that we've used in the past. All right, sum of squares within treatments is simply the sum of the SS inside each treatment. So that's 8 plus 10 plus 28. And how do we get that? Well, we're given that right here, right? We're given all 3 sum of squares right here. Then SS between subjects. All right, so this is a longer formula. Oh, but I missed this. So SS between treatments, okay, you could do the sum of T squared divided by little n minus G squared over big N. Or you can always just do the simplified formula of SS total minus SS within will give you SS between treatments. All right, on the next question, we'll go over these steps. However, you won't really ever have to do them, but I recommend you do to check your work. All right, SS between subjects. So that's the sum of the P squared over K minus G squared over N. K, number of groups. P are the person totals. And then we know G squared divided by N, right? G squared is the grand total. Big N, the number of participants in the whole study. So you go up here, and these are all the P totals. So you plug these numbers into the formula, and So the first step that you should do is you should do 6 squared divided by 3, 12 squared divided by 3, 9 squared divided by 3, 6 squared divided by 3, 6 squared divided by 3, 9 squared divided by 3. And then leave this g squared minus 18 outside, right? Because you know you have to get this value first and then subtract this value from it. So you can see I did everything step by step. 6 squared divided by 3 is 36 divided by 3 is 12, etc., 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 etc. When you do all of these calculations, you'll get 12, 48, 27, 12, 27. Minus 128. 138 minus 28 equals 10. SS between subjects is 10. Find SS error. That's simply SS within treatments minus SS between subjects. And we got these values. We calculated them above. So it's 28 minus 10 equals 18. And then the numerator and denominator for our F obtained will be MS between treatments and MS error. So MS between treatments is simply SS between treatments divided by DF between treatments, which is 28 divided by 2, which is 14. And find the MS error. MS error is SS error divided by DF error, which is 18 divided by 10, which equals 1.8. F critical, you're going to go to the table and use the degrees of freedom of between and the degrees of freedom of error. Okay, so the degrees of freedom between was 2, and the degrees of freedom of error was 10, right? 2 and 10. And we calculated those above. And then when you go to the F table, just like we did in the last test, you just find the F critical value. Always look for if they're asking for 0.05 or 0.01. All right, remember, 0.01 are bolded. 0.05 is non-bolded. Don't assume because we do a bunch of 0.05s in class that I won't ask you a 0.01 on a test. All right, it's the difference of a bolded number and a non-bolded number. Find F obtained. F equals MS between treatments over MS error. It's 14 divided by 1.8 equals 7.78. What do we do to the null hypothesis here? We're going to reject the null hypothesis because our critical value of 4.10 is less than our obtained value, or our obtained value is larger than our critical. And then we could find eta squared, all right, which is the proportion of variance explained by the treatment effect. All right, it's very similar to R squared, and that's simply, you could use 2 formulas, but I recommend this one since you only have to use 2 sum of squares as opposed to use 3 different ones. It's just easier not to make a mistake. And then, so you do SS between groups, right, or between treatments, right? It's the same thing, right? You see right here, groups, treatments, right? They mean the same thing. Over SS between groups plus SS error, 28 divided by 28 plus 18 is 0.61. And then this is the full ANOVA table with all the data plotted. And that's that question. All right, so for this question, it's the same thing. All right, so it's all the same steps, right? We just went over what all these values mean. Now you just got different values. So I'm not going to go over those because it's the same steps, just using the numbers that are given here. But I will go over finding SS between treatments, okay? So remember, you can always do SS total minus SS within to get SS between treatments. But you can also solve for SS between treatments, right, to check. All right, so that's simply the sum of t squared divided by little n. Remember, little n represents the number of participants in each group. Big N is the number of participants in the entire study. The t squareds are right here. They're the total sum of the scores in each treatment, right? So you just use those values and plug them into the formula. So all you're going to do here is 24 squared plus 36 squared plus 48 squared divided by 6. Now you can see the formula is t squared divided by n, and you can do it both ways. So for any anything that's set up like this with the ANOVAs, you'll see that it will work both ways. You could do 24 squared divided by 6 plus 36 squared divided by 6 plus 48 squared divided by 6. Or you could simply just do 24 squared plus 36 squared plus 48 squared and then divide by 6. So I think about it logically, you will get the same number. And then then subtract that from g squared minus n, and you'll get 48. Again, all the other steps are repetitive from what we learned above. And that's a repeated measures ANOVA t-test.